Hey everybody, thanks for joining. Once again, my name is Apoorva Dave. I will be your friendly voice of the next 45 minutes or so. I want to thank everybody for joining. Erwin, Jake, Kenneth, Robert, Steve, really glad to have you here. I'd like to get started quickly here. Here's my plan. A little bit of slides, a whole lot of demo, give you a feel for what Sysdig Cloud can do and some of the challenges around container native monitoring. Before we get started, Zoom controls should be in your upper left-hand corner of your screen, and there's a Q&A window there and a chat window there. It would be really helpful if we could start this presentation by having you send me a message via chat and let me know where you are in your Docker journey. You could just be trying it out. You could be running it in production. You could be running it in production with an orchestration system like a Kubernetes, Mesos, or Swarm. Wherever you are, I would love to know what you're doing currently with Docker. So where you are in the process. If you're using an orchestration system, if you're in your own data center or in AWS or something similar, any of those things via the chat window would be greatly appreciated. And for any of you who've attended my webinars before, you know that I really like to keep it interactive. So this way, asking questions right off the bat is my way of starting. There's also a little bonus here that you might be interested in, which is I love it when customers or prospects stump me and ask me a question that I can't answer. Now, it's actually not that hard. There are a lot of people out there who are way smarter than I am. And the beauty is, if you do stump me, I'm going to send you a t-shirt. I'm going to send you one of our really cool What's Inside t-shirts. I should be wearing one today, but I'm not. I'm wearing my really nice polo. So let's see, we got some folks chatting in here. I'm going to open up a chat window so I can see. Cool, Kenneth is doing an initial investigation of Sysdig. Robert is just getting on the Docker bandwagon. Cool. Okay, Kenneth, that was Kenneth and Robert. I'm waiting to hear from Peter and Steve. I think they're just going to be chatting in here momentarily. In the meantime, why don't we get started? Please interrupt me with questions anytime you want. Use the Q&A window. Either I will answer them during the presentation. My colleague Knox, who's here, may answer them via Q&A, or even better, maybe you'll stump us and we'll have to get back to you on an answer. In the meantime, let's talk about monitoring containers. Now, if you're, you're getting into the process of looking at containers, maybe you're using them in dev and figuring out how to move them through staging and prod. Typically, what you'll see is that the models that previous monitoring products used kind of break when you start moving to containerized and microservice-based infrastructure. And we'll talk about why that is in a moment, but this is kind of the history of Sysdig. We came around with the idea that, we need a model for monitoring and analytics that fits in with the new containerized and microservice-based approach to looking at your infrastructure. So if you, like Steve, you're at the doorstep of using containers, you've opened the door, but you're not sure what's on the other side, a product like ours will potentially help you do that because we're built with those issues in mind. So let's go through why monitoring containers is different, and then I can tell you more about Sysdig and show you some cool stuff. So 3 big issues with monitoring containers. Legacy monitoring approaches can't see inside containers. So containers are designed to be black boxes. Why? Really good for dev in terms of making your code portable and abstracting away the underlying infrastructure so that you can run anywhere. Problem is, when you're running a container in production, you actually need to be able to see inside. Now, in previous generations of monitoring, the typical way, not the only way, but the typical way that people would be monitoring things is they'd drop an agent in user space, usually on a virtual machine, and you're good to go. You can kind of see everything that's going on. But running a monitoring agent inside a container isn't really viable. Let me clarify that. Running a monitoring agent inside each of your containers isn't viable. Why? It's fundamentally breaks the Docker model of process isolation. The whole idea behind Docker containers is that they're lightweight, portable with as few dependencies as possible. You start throwing monitoring agents inside and all of a sudden they're bloated, they're heavy, they're not as portable, they have more dependencies, and frankly, they have more attack surface as well. So none of that sounds pretty appealing if you think about that. So that's an issue we need to address. And finally, lots of people are moving to containers in order to create microservices. Yet microservice monitoring requires a pretty different approach. It's no longer about the host, so not even about the container. It's about a service, which could be made up of many containers spread in many places and only relevant to part of your development team. So we need to address all three of these issues in order to do a good job of monitoring a containerized infrastructure. Okay, so that's, if you will, that's the problem statement. That's the issue that we see a lot of customers facing. Now let me go all the way down to the technology level and tell you a little bit about the technology we invented, and then I'll bring that back up and say, well, how do these two meet? So we saw this issue with containers, and like, well, how do you get the visibility inside it? How do you understand what your host is doing, what your container is doing, but what the app inside the container is doing in a way that fits with the Docker model? And we came up with this idea called ContainerVision. ContainerVision is deployed as an additional container on each of your machines, but here's the beauty of it. It can see inside your other containers from the outside. In addition to doing that, it understands what's going on beneath your containers in terms of the host, your container orchestration, and your network and infrastructure. How, you may ask? Let's dig in a little bit deeper. So here is our, kind of our simplified host, if you will. It's, for the sake of explanation, it's got both containerized applications and non-containerized applications running on it. And it's all communicating to a kernel, typically a Linux kernel, and you're trying to figure out how to instrument this thing. So along comes Sysdig, and what we do is we actually instrument the kernel of your host. And we do that by deploying a kernel module to your host. And this allows us to transparently instrument every single container, every single application, every single process that is running on your machine. And we see this from a single instrumentation point. And this is what makes it so powerful. It's really, really lightweight. You have one instrumentation point. You see what's happening everywhere. And then, let's see here, we have a container running on that machine. And all the data we collect and all the metrics we collect are run through this container, aggregated, and then sent back to the back end where Sysdig Cloud does its magic. Now, the back end could be one of two things. It could be our cloud service. So if you prefer to not run a large analytics backend, we can do that. If, however, you're the kind of company that would like to keep the data yourselves, you can deploy our technology as software. You can run the backend yourself, and then the Sysdig container would be pumping that data to your backend. Okay, so this is Sysdig ContainerVision, and the key here is from a single instrumentation point from the outside, we can see what's going on inside your containers as well as underneath your containers in the host and the network and the infrastructure and your orchestration systems. I want to stop here and ask for questions. This is usually a good place for questions in the sense that people really want to understand this instrumentation. It's the magic of our system, and I will definitely show you this at work during our demo. But let's take a moment here and see if you have any questions. In the meantime, it's a tea break for me. No questions. You guys are floored. That's what I think it is. What do you think, Knox? I think they're just stunned that we could do this. I think that's the case. Let me answer a few questions that people usually throw at me. First one is what are the requirements around deploying this agent? So our container is deployed as a privileged container. And before you deploy it, you also do need to, install kernel modules on, or kernel headers, I should say, on your Linux host. So, at first, for some people, that's like, oh, whoa, hey, wait a minute, that's different. And that's actually why we initially created our technology as an open source technology. And if you go to sysdig.org, you will see our open source visibility and troubleshooting tool by the same name. And this is used by hundreds of thousands of people. Our kernel module is open source, so you can see exactly what it's doing. And that's given people a lot of confidence to deploy our technology, whether that's financial services companies, healthcare companies, the government have all deployed this technology. We'll also argue that our methodology actually reduces security risks as opposed to increase them, which is a discussion for another time. Okay, so you've all taken me at my word that this is some amazing stuff, but now I want to show you what we can do here. Oops, sorry, pardon me. When you think about traditional infrastructure monitoring products, you get alerts on your CPU, your memory, your disk, how your host is doing, maybe how your network is doing, and kind of that's basically it. And from there, you can kind of extrapolate what's happening with your code. We've changed that model around a bit and given you much better visibility. With Sysdig Cloud, you really get 3 layers of visibility. First of all, service-oriented performance management. As we've talked about, you're moving away from the monolithic app concept and moving instead to modular services. So can we give you visibility in how those individual services are performing, regardless of where they're running? App intelligent monitoring and alerting means letting us help you kind of automatically understand the apps that are running and give you the right data at the right time for those apps. And finally, trace-driven troubleshooting. If you think of service-oriented performance management as going really high level and abstracting away from containers or code, trace-driven troubleshooting is getting all the way down into the nitty-gritty. And I think another place you'll see that we really differentiate is we don't just give you the little chart that says, hey, something's wrong. We actually help you troubleshoot that in some pretty interesting ways that I'm excited to show you. Let's dig into each of these 3 for a moment, and then we'll hop into the demo. So service-oriented performance management. As you probably know, when you switch to a containerized version of your application or re-architected container version of your application, and you use an orchestration system, those containers are spread out. And they're not typically spread out manually. That is, you're not deciding, service 1 goes on host 1 and service 2 goes on host 2. A brain like Docker Swarm or Kubernetes or Mesos or DCOS is deciding where to put those containers for optimal resource usage. Now, because of that, it's really hard to monitor your logical services. Like imagine purple here is service 1. How's service 1 doing? Can you tell me what its response time looks like, what percentage of the allocated resources it's using? It's pretty hard to answer those questions. But in fact, you probably want to start monitoring from that level before you get down into an infrastructure level. So with service-oriented performance management, you monitor applications and logical services first, not just hosts. So let's see how we do that. Well, not surprisingly, we reorganize the information. We do this in Sysdig Cloud. Once we capture all this underlying data, we can on the fly reorganize it so that we can give you a service view. And so you can answer questions like, what's the response time of my standard service that's currently distributed over 3 data centers? And what are the slowest queries for that service? So that would be pretty hard to do with your kind of legacy monitoring tool in a modern Dockerized infrastructure. How we do this is through integration with your orchestration systems. So we do not make you manually input a lot of information about your services. We're discovering this in real time through integrations with Kubernetes, Docker, Mesos, and even underlying infrastructure components like Amazon Web Services or any of the clouds, and basically other sources of information that you have. We can pull that in and then aggregate the data in the proper way to show you the slice of your infrastructure you're trying to look at, whether it's logical or physical. Stop here, ask for questions again, because this is another good place where people typically have a lot of questions. If ContainerVision is like our kind of crowning jewel differentiation in terms of technology. This integration with orchestration systems is the second one, where because we do this, we can really change the way people look at their infrastructure. All right. The next thing we need to do is enable more of a kind of dynamic alerting environment based on the way your containers may be shifting around. So when you have kind of a complex containerized environment, you can't be spending time manually tuning your monitoring system to adapt to the fact that a new container spun up or a new version of this application came in, so on and so forth. So we've automated that process. Through our instrumentation, we automatically discover your applications. So you may be comfortable or familiar with the idea that once you deploy a monitoring agent, you tell it what app checks to configure, you tune it to collect the right data. We automatically discover all of that, and you don't need to deal with any plugins. So we'll just figure that out. We also have mechanisms to augment our auto discovery in the case that you have custom applications or you've tuned open source components. Finally, next, we give you templates to view all this stuff. So you don't have to build dashboards out of the box, you'll have them. And we do zero config custom metric collection. So imagine collecting all your stats D and JMX metrics with no agents inside the containers. And frankly, you don't have to do anything. If you're spitting out stats D and JMX today, we're going to capture them, even if you're sending them off to a different monitoring system right now. And finally, we have some forms of anomaly detection in the system. So if you're the kind of person that wants to use anomaly detection to help you highlight potential problems, we can do that as well. All of this type of app in intelligent monitoring and alerting allows you to do things like respond to developers spinning up a new service last night without letting you know. There was an emergency, they needed to spin this up, they went for it. As long as Sysdig's being deployed along with all your applications, you'll automatically see it, you'll automatically start collecting data with it. I like to call this slide Logo Soup. This is my, stop and check in with you about the types of applications and infrastructure we can automatically instrument. Two things to do here. One, check this list, see if there's some stuff that's important to you. If you have questions about it, as always, just use the Q&A and drop it in. Also note, there's probably some stuff here that you want and we don't have. And this is a place where you can either let us know and we can help create an automatic app check for you, or you can create your own. Our system enables you to do that. And the beauty of that is once you've created that app check, we'll auto discover it from then on out. Stop here, give you a moment to absorb this panoply of options. I'm not sure that's the right word, you think. All right, last element before the demo. Actually, let me ask, I should ask the audience. We haven't gotten a lot of questions yet. Nobody has stumped me, but let me just check in. Who's interested in seeing a demo? Anybody interested in seeing a demo? If you are, chat me in, use the chat, say yes. Yes or no. I guess you could say no if you're not interested as well. Yes, absolutely. Yes, definitely. Okay, so what they meant to say is stop showing me these slides and show me the demo. I think that's what they're saying, that we're almost there. I just wanted to give you this last bit of context, which is trace-driven troubleshooting. So here's the story. Oh, Jonathan says the slides are okay too. All right. Thanks, Jonathan. I appreciate that. Okay, so trace-driven troubleshooting. If you think about most monitoring tools, like they do a good job of two things. Typically, they show you a dashboard, right? So you can see the pretty line. That's really important. You need to have that on a big monitor so everybody knows what's going on. And they alert you. They alert you when you've hit a threshold, when something looks bad. That's also really useful. Where do you go from there? In most systems and environments, you're left to your own defenses to drop onto a Linux host, SSH in, use tools like HTOP or maybe your logs and grep them to figure out what the problem is. We wanted to help solve this troubleshooting workflow in a much more powerful way. So we take you from dashboards to being able to correlate events with the system, all the way down to potentially having a trace file with every single system call on that machine when that alert fired. So you can get really, really deep in terms of troubleshooting. So, demo God's willing, I'm going to show you all of that in a moment. Here's a good example. Replay the state of my system last night when the alerts, the service alerts fired 5 minutes before our app went down. Show all the system calls from the containers we destroyed. So this is really cool in the sense of, if you think about my earlier section, containerized environments tend to be very dynamic. And because of that, things come and go. So a container starts behaving badly, you kill it. And that's the right thing to do. But how do you figure out why it was behaving badly? What do you use to do that? We've enabled a system to help you do that more effectively. All right, I'm going to stop here and see if there are any additional questions. I see I've got one. Kenneth, what's the best way to get the full list of metrics you capture? This is actually a really hard question because we're constantly adding application checks that can go in and by default get everything that a system provides. So for example, imagine you're running an Apache web server. Within our application check, we can tell Apache, hey, give me asterisk metrics, and that will give us everything that Apache has. We do, however, have a cloud metrics dictionary available on our support site and within the application. In fact, when I go in the app, I can kind of show you where the link is. We also have tooltips that tell you what each metric are. So that should give you a sense of it. But for particular application checks, so the higher level app checks, we may not have a full list out of the box, but we can work with you if there's a particular element you're looking for. Final element on top of there is if you're doing custom metric, well, sky's the limit. We can collect anything that you're putting out. Another question from Steve Knox. I think the audience is warming up. That's the sense I'm getting. I'm liking this. Another question from Steve is how long are metrics maintained? So we maintain metrics forever. I'm going to stop and let that soak in. Forever. We don't purge our metrics today. What we do is we roll them up over time. So for the kind of the first 6 hours, you have full granularity of your metrics, and then it subsequently rolls up into higher and higher periods of time until at a year, I believe we're saving basically a daily data point, if I recall correctly. That gives you a ton of runway to do comparative work, which is pretty important in terms of troubleshooting or trending. One more question came in. What's the difference between open source and paid versions? Jonathan, I'm going to cover that in a little more detail at the end. At a high level, the open source tool is designed as a CLI-based tool to troubleshoot a single host, where the paid version is the UI I'm about to demo with the ability to aggregate data from thousands of hosts, tens of thousands of containers, and give you a much more streamlined workflow for troubleshooting those types of large-scale environments. Great questions. All right, demo time. Here's what I'm going to show you. I'm going to show you a small environment. I'm going to start kind of with and without orchestration. I'm going to show you how to deploy a Sysdig agent. So I don't think I've ever been on a demo of another monitoring tool where they actually just said, I'm just going to show you how to instrument the system, because for us, it's so fast. Auto discovery does all the work, so it's crazy easy. Then I'm going to walk through these core elements I talked about: service-oriented performance management, deep troubleshooting, and application intelligent monitoring as well. All right, so give me a moment here to switch over, make sure my environment is completely set up properly. All right. Pay no attention to the man behind the curtain, futzing around in this environment right before the demo. Forgot to reset it. All right, so welcome to Sysdig Cloud. And let's start by giving you a sense of our demo environment. It looks like my internet connection is running a bit slow, so you may see a little bit of a delay here. Okay. This is the physical demo environment that we are running in Amazon right now. So there are a bunch of hosts. They're all connected together. You can see this is real-time data. It's dynamically updating. It's also a total freaking mess. I don't think this would be particularly useful for troubleshooting anything, minus maybe a host falling over. And that's not really the hardest problem to troubleshoot. Now the beauty here is this is all dynamically created. We get this information automatically. You don't have to do anything about it. But what's more interesting is taking a service-oriented view to this data. So abstract away from the host and think about the containers that are running on top and the services that they're trying to accomplish. And I clicked on this ContainerVision demo. This is the same information, but instead of being aggregated by host, we're now aggregating that data by service. And you can see something pretty interesting here. Well, you see a topology, and you see services like Amazon ELB routing to our Java application and our web app, the two main apps in this demo environment, and a bunch of backends. It goes a little bit further in that this, we like to call this view Google Maps for our infrastructure. So this web app is red. Let me zoom in here. And we can drill in down to the individual containers that are running in this service. So what we see here is that for the web app service, we're running HA proxy, which is load balancing across our WordPress cluster here. So again, once again, this is all dynamically done. You can slice and dice this view any way you like. You can have tons of options for what data you show in the environment, and how you want to control it. So you may be asking at this point, how did you actually get this data? So let's instrument a system. You should be seeing a different environment now. This is my personal environment. It's a little bit sad right now because there's no data here. So let's get at some data. Hop over to a terminal window, and let's log into AWS. Let's see what I've got running here. Okay, I've got a couple things running. I've got WordPress, MySQL. I've also got this Slack bot running because I'm futzing around with the Slack bot. We can talk to you about that later. Let's instrument this system. I go in here to settings and say I need to install an agent. You'll see here are the commands for setting up your Linux host to install the kernel module, the kernel headers, I should say. And then here is the Docker run command that pulls down the Sysdig agent and runs it. So let's hop over here, run that. Whoops, looks like I have a little error here. Back up. There we go. Looks like I had a typo there. Okay, so now what's happening is basically your Docker engine is pulling down the most recent version of the Sysdig agent. Of course, if you use an internal registry or you want an air-gapped installation, that's available. But it's setting up the container, it's installing the kernel module, and now it's starting to automatically find system data, container data, and discover your applications and send all of that information back to Sysdig Cloud. And we are using the cloud version for this demo, but of course, if you were using your kind of your own software version of Sysdig, that would work as well. Kenneth just asked, does this need to run as root? Essentially, when you're running a privileged container, you are running it as root. And we need that access in order to instrument the kernel of your system. Obviously there are some concerns with that. What we've found when we've talked to very large Fortune 500 organizations and worked with their security teams is once they've understood the model, they actually see that it could reduce their security risk versus increasing their security risk. So if that is a concern for your organization, just talk to us about it. We really appreciate those conversations, and we'll help you figure out if this works within your security model. All right, so let's hop back here and now go into Explore. And typically, it takes about 10 to 30 seconds for this data to first appear, and then we're collecting it in real time. But there's my host. And check this out. I'm going to drop in here, and here are my containers. And so automatically, I found the host. No surprise. I've seen the containers. That's nice. Now, this one is cleverly labeled MySQL. Let's take a look at this. When I click on MySQL, I'm going to get this pre-built view. And right now, this is an overview by process. So you can see that, for the MySQL container, this is breaking down processes on the machine. But this is MySQL. So let's do this. MySQL. Let's look at MySQL. And now look at the data I'm getting from MySQL. Requests, errors, requests versus average, request versus errors. And this gets more interesting here. Top queries by number of requests. So you can get application specific in terms of top queries, and slowest queries. So you can start understanding where is your service not performing well. So this isn't information like CPU, memory, disk. This is deep information about the application itself. And this is application intelligent discovery and alerting. Out of the box, we figured this out. We found all this. So in just about 2 minutes, maybe let's say 3 minutes this time, I instrumented a system. I saw all the containers, and I auto-discovered the fact that MySQL was running on this machine and started to collect MySQL-specific metrics in order to show that to you. If you were here in the room, I'm sure you would be applauding at this point. But this is also another good place for questions. Please let me know what you think about this instrumentation model. And in the meantime, I'm going to hop back to our more complicated demo environment to show you a bit more. Questions? All right, let's keep rolling. So as you saw in the other environment, we have this mechanism called Explore, and this is really powerful. This is like HTOP for your entire environment. It gives you an interactive way to look at all your data in a really powerful table. This table is fully configurable, so you can remove columns, you can add columns, all that good stuff. More importantly, you can group this information, much like we were looking at in those topology maps, where right now you see that I've got a host and container-centric view. But instead, I can take a service view, and we have a lot of pre-built groupings based on commonly used orchestration systems. Now I'm grouping this via service, and you'll see I've abstracted away any kind of physical elements here. So if I take WordPress, for example, our HTTP service, then I see the WordPress service, and I see the containers that make up that service. Now, when I click on WordPress, what you'll see is that the data below is aggregated across all of those WordPress containers. So if I'm asking, how are my processes doing across my WordPress containers, this view, or my WordPress service, this view gives me that. And then, of course, I could click down into an individual container to just see information about that container. Steve just asked a question if these colors mean anything. And yeah, absolutely. They're configurable thresholds. So you may decide, for example, that for CPU percent, when anything hits 80%, it's running hot. And if it's below, let's just say 30%, it's green. So let's do that. And you'll see we take the colors away. We don't show everything as green because that would be really obnoxious. Just to show you this again, let's say 1%. There you go. You get a sense of how those colors work. Those are configurable kind of across the system, so it's pretty powerful. We also give you views into your AWS services. So for example, if you want to see all your EC2 instances or you want to see your ELB instances, they're all kind of here. This is a basic CloudWatch integration. It's really, really powerful. The most interesting thing is that we can actually give you more data into RDS than you can get elsewhere. Okay, so one more question came in. Oh, is this Docker Swarm? That's a very good question. So we're not, in this environment, we just actually tagged everything manually via our agent. It works very similarly across a number of different orchestration systems, just the terminology is slightly different. So if you see in our pre-built grouping mechanism, we have groupings for, if you're using Amazon Elastic Container Service, Docker Compose or Swarm. If you're using just raw AWS, if you're using Kubernetes, Marathon, Mesos, or if you are kind of mixing those up, you can kind of, do custom groupings. You can create your own groupings and save them as well. So we work out of the box with Docker Swarm, with Kubernetes, with Mesosphere or DCOS, depending on what you're doing there, as well as Amazon Elastic Container Service and Google Container Engine. Let's dig in on a couple other elements here. So let's just click on Cassandra. We get an overview by process for Cassandra. We say, well, I really want to see this, app-specific stuff on Cassandra. So let me take this, and now I get this kind of cool stuff like write request, read request, pretty powerful Cassandra data. But in fact, this does not even have all of the Cassandra metrics we collect. So you can hop over to this metrics tab and you can actually see every single metric that we collect this is for Cassandra. We get, JVM and JMX metrics out of the box. So we can search for a JVM overview here. Click on that. And you can see we're getting some information. Looks like we're not collecting garbage collection right now. For any of these charts, you can zoom in to get a better sense of the data. Okay, guys, so far, I think Kenneth is winning the question marathon. He's rocking them in. I think Steve might be in second place, but it's close. So Steve, you might want to hop back into this game. Kenneth asks, what's the average CPU memory overhead for running Sysdig? It's pretty small. Typically, Sysdig uses 1 to 2% of your CPU and 4 to 5K of network. I don't remember offhand the memory requirement for the Sysdig agent. But of course, the beauty is we can monitor Sysdig agents with Sysdig. So you can see here that these Sysdig agents are using about 7% of the 7 to 9% of the utilization of the systems. So memory utilization is probably our highest component. Let's hop into the Sysdig agent and do an overview by container. There you go. Kenneth, I love the fact that you asked that question because I love to show Sysdig monitoring Sysdig. That just makes me very happy. Excellent question. Well done. Can we send Kenneth a t-shirt just for asking that? Yeah. All right. Kenneth, we're going to send you a t-shirt just for that. All right, cool. So we've shown you kind of general explore. We've shown you getting down into custom metrics like JMX metrics. We can do that with StatsD as well, out of the box StatsD collection. I won't do that because it looks exactly the same as your JMX metrics are. The last element we need to talk about to really have a kind of complete system here is alerting. And so in order to do that, I'm just going to hop over here to Mongo and press this bell. You can create a bell here. You can do it off of any panel, basically, where we're showing you a metric. You can add an alert. Now, our alerting is what I call adaptive alerting. So think of in your previous world, you typically set up alerts per host or per application, but instead we've implemented an adaptive alerting model, which allows you to set an alert per service. And then as your container orchestration system grows and kills your container count, that alert applies to the entire service. And that's incredibly powerful. So it means that you can have fewer alerts that focus on how your services are performing. So let's run through this. Let's run through this. I'm sorry for the interruption. I got a couple questions in that I will circle back to in a moment. Okay, so we're going to set a manual alert here, and we're going to alert when the average byte exceeds 10 megabits per second. By the way, you can also use an advanced alerting model here, which allows you to do Boolean logic. So if we wanted, for example, the bytes to exceed a particular amount, and we wanted our memory to exceed a particular amount before we get alerted, you can do that as well. You can also segment this alert. So imagine you have a service that's running in 3 data centers. Oh man, there are so many good questions coming in. I want to rocket through this alert stuff and get to these great questions. So you can segment your alert out by different areas. So for example, imagine you had a service that was running in 3 data centers for reliability. You could segment that across those elements. So for example, if you were doing it in the cloud, you might segment by availability zone. And now I'm setting up 3 alerts at once. One for the Mongo service running in AZ1, one in AZ2, and one in AZ3. You can specify some information to make the alert more readable to you, and then you can configure where you get the alert. And this, this is really, really flexible. So you can send alerts to multiple channels. You can finally address where alerts get sent. It could be email, PagerDuty, Slack, Amazon SNS, Victor Ops Genie will be coming this week, as well as a generic webhook to trigger an activity. Curious to know how many people out there use Slack today. I'll wait for that. In the meantime, while people are commenting that, the other thing you can do is you can capture a trace file on an alert trigger. And as we were talking about before, Sysdig Cloud is based on this open source tool, which is designed to analyze your system calls. And you can capture this file that shows you every single system call that was happening on the machine when the alert was triggered. And I'm going to show you that in a moment here, but you can enable that here and define some filter options to minimize the size of the file and then go from there. It's really, really powerful. And I'll show you that in a moment. Okay, so let's just say we've created this alert. I'm not going to actually create it. The questions keep coming in that are somewhat related. I'm going to hold off on a few of them. Steve just asked, who defines these alerts? The container owner, capacity or support group, etc. It really depends on your workflow. So in some organizations, we see like a infrastructure team that's responsible for that. In other teams, they kind of allow you to isolate parts of the infrastructure and have a team separately manage those. Those can work either way. So let's now explore a particular alert so you get a sense of what you can do there. So in order to do that, I'm actually going to pull up my own Slack environment here and show you what an alert looks like and how you troubleshoot it. Give that just a moment to come up. Oh, cool, I'm already in that channel. Okay, so let me find the one that will be interesting here to troubleshoot. Yeah, okay, so we were just looking at Mongo. So we see this alert, we got a traffic spike on Mongo. We can view this notification. Now this takes us into the events tab within Sysdig. And what the events tab is a running list of every single event that has fired in your system. Event, of course, is a contextual piece of information that allows you to help understand what's going on. Now, we can not only show you alert events, we can show you custom events. So things like Docker information, like container kills or spin-ups, Kubernetes information, CI/CD commits, so Jenkins commits, GitHub commits, your own, what if you've built your own system for CI/CD, we can import all of that information and allow you to contextualize your metrics. What that looks like is at first you see something like this, which is like, oh, well, here's my alert, and here's where it kind of triggered against the problem. Now, we can do two things here. We can compare to now, or we can explore this event. Let's click on Explore, and what this does is it's going to take us back in time within the Explore tab to exactly where that alert fired. So now I can explore my entire infrastructure at the time that this alert fired. So you see here, I pulled it. I'm in my metrics view, looking at this particular metric, and right now I'm looking at data by server port. So we see all the data is on server port 80, and here is an event overlay. This would work the same for custom events as it would for these alert events, and I'll show you that in a moment. But we can see, okay, we know the alert's there. We understand why the problem's there. Now we need to troubleshoot it. This view isn't really helping us. So we know that Mongo is running. If I click here, we know Mongo is running on this host. So why don't we just look by container? Let's look at the container name. And we look at this and we're like, wow, okay, we see Mongo is the only container running here, and its traffic looks steady and didn't have a huge spike. So there must be something else going on this system. So let's go down lower level from the container. Instead, look at all the processes that are running here. So now if I split this out by process name, this is interesting. So there is a process running called main, which spiked up in traffic at the time that this happened. And in fact, I can get down to the command line if I wanted. So now what do I see? Oh, this is user bin Python. Okay, stress system. This is a system stress test that's triggering this issue. So we were able to get down to a level well even below our containers in order to understand what's going on here and troubleshoot it. So as I mentioned, and Kenneth, this is going to answer your last question about capturing full process metrics. So we capture a ton of information regarding what's going on at a process level. And as I mentioned before, we can enable you to do system captures. And these system captures, I want to give you a sense of what they look like. So let's see here. I'm actually not too familiar with these in the system, but you can drill down into these individual trace files within Sysdig, and we'll pull up a view which gives you a metric, process name, process ID, and process arguments that you're looking for. This to me is like, it's like 1% of what open source Sysdig can do. So you can see here, it's broken down by, as I mentioned, by CPU utilization. I could click on Python and I could see the process ID, and I can click down into the process arguments. If you wouldn't mind here, if I can hop back to my my Amazon Linux instance and instead run Sysdig. This is our open source tool. I can spell it correctly. See if I got that right. This is the open source tool. And as I mentioned earlier, when you trigger one of those alerts, you can trigger a capture file to capture everything that was going on in your system at the time the alert fired. And from this point in time, you can do incredible things here. So you can get down to every piece of information that you're looking for, down to spectrograms of how things are running. You can look at page faults. You can look at process errors and FD usage. You can drill down into containers themselves. So you can, do this. We could, let's do, oops, wrong one. Go back one and do, there you go. So we're digging into basically every single command executed at the kernel level via MySQL. Pretty cool and pretty powerful. And no other tool out there allows you to do this level of instrumentation. All right. One last thing while we're talking about correlation, I mentioned we could also show you custom events in the system. Let's take a look here at this. Here we're getting an alert saying our web requests were low, so that's interesting. Let's look at that event. That's, again, we were triggered by an alert, so we have a very similar workflow to what we were seeing before. But this time we're going to troubleshoot it a little bit differently. And of course, this is kind of a, a made-up scenario, but I think it's useful for seeing what's going on. So you can see the drop here, and now we're going to explore this event. And when I click on Explore Event, it's going to do the exact same thing as before. It takes me back. I need to look at my web server and SQL account. This from the service. So now what I can do here is actually zoom on this part of the problem. And look at all my events. So from here, what I could do is say, I'd like to see all the events on this environment. And let me look at a longer period of time here. Where we're going with this is that we can actually show you events like a rollback has been completed. And this rollback or deploy could be related to an event like services going down in performance. So what you end up with is seeing not only the alert in your environment, here's my alert, but we can clearly correlate events like containers killed or starting a WordPress deploy resulting in performance going down, and then performance coming back up when we have started the rollback and saying, you know what, that build didn't work, let's roll it back. All right, so what you've seen in the system, we started with some basic dashboards about our systems. And in fact, maybe I'll pull one up just to remind you where we started. We started with some basic dashboards regarding how you look at a full stack view of your applications. We looked at topology maps. We looked at exploring your infrastructure through an HTOP-like interface. Then we went through a troubleshooting workflow around finding the problem underlying container performance, which was a non-containerized problem. And then we even talked about correlating events and metrics. We did all of that based on an instrumentation model where you can do a single Docker command to get this monitoring running. And of course, I didn't mention this before, but if you are running an orchestration system, it's really easy to put that in as part of the manifest file. So that is kind of the nickel tour, if you will, of what you can do with Sysdig. And I would love to get additional questions. There are a bunch of questions I know that I haven't answered, so I'm going to start rocking through those. But I would love to get more questions as they come to mind. So Peter asks, I probably mentioned this earlier, where's all this data stored? Peter, I did mention it earlier. It's actually your choice. So you can either use our cloud service, in which case we store the data for you, or you can run our technology as software in your own data center behind your firewall, in which case you store all the data. Kenneth asks if I have an example of showing and tracking the performance of same containers coming and going. I don't have that handy, but there are a number of ways you could do that in the system. Kind of depends. You correctly put same in quotes. So it depends what you mean by same, but you could do this in a few different ways. For example, you could organize your containers, much like you saw me do before. You could organize them by container, for example, container name. And so if it's the same container, but the name is coming in, the name is staying the same, you'll be able to track that over time. Similarly, you could have everything deployed as a given service, and that would track that. And then you could do a breakdown by individual containers as they come and go. Hopefully I answered that question. Let's see, not sure if this makes sense, but can you see swarm level utilization data on your dashboard? You absolutely can. As I mentioned, I'm not in a swarm environment per se, but for all of the orchestration systems that we support, you'll see we have pre-built dashboards here that would show you information. So for example, with Docker Compose and Swarm, you can look at an overview, projects or services. I'm happy to click into this. Remember, there won't be any data here because I'm not using this environment. But you can see there's a request count by service, projects, top services, containers by host, slowest resources and top resources. We're getting this information because it's at the Docker container level. You would get a very similar thing with Kubernetes, where you can do namespaces, overview pods, and replica sets, and so on. Similarly with Marathon and Mesos. Great question. Let's pull up the questions again. So many good ones. Let's see, we answered the one about defining alerts. We talked about or another question was, Kenneth, was, do you have integration with Cassandra as your database? So yeah, absolutely. So actually, two ways to answer that question. One, we run Cassandra as part of our offering. So that's our underlying metrics data store. You may be asking if, if your organization's running Cassandra, is it automatically integrated? Yes, absolutely. And in fact, that's a little bit of what I was showing earlier in terms of clicking on that pre-built Cassandra dashboard. Great questions. Let me see here. I think we've got a few more in Q&A. Robert asked, do we have a host level view? Absolutely. I'm hoping that you saw that. I have no problem just opening that up again. Let's actually do this. So there are two kinds of ways of thinking about hosts. First of all, you could do grouping here. And so now this is one host level view. The other thing you could do is click on this. And now you can see this overview by host. And now I'm looking at this particular IP address. Good question. Data stored, we just answered that one. Do we have any containers that monitor hosts? Robert, I didn't understand your last question there. Do you have any containers that monitor host? If you could clarify that, I'd be happy to answer. Gentlemen, I want to congratulate you. I'm pretty sure this is the most questions we've ever gotten during one of our overview webinars. So I want to thank you for that. Robert is not giving up just yet because he's got one more question. So he's, Robert, you're asking if we have, can we alert on host level events? Absolutely. You can do anything you want. Anything I showed you in terms of setting up alerts, contextualizing related events, you can do it at the host level. There may be, I realize there may be one different question you're asking, and you may be asking if we can alert on an event like this, like a custom event, hey, this container was killed, send an alert. The answer is not today. That's something we're working on, and we expect to have that very, very soon. All right, before we wrap up here, see here. I would like to just tell you about the product line. So folks asked earlier about the differences between our products. Sysdig Cloud, that's the SaaS offering that we were just demoing there. It's $20 a month a host, and it's discounted for large environments, monthly or annual. Sysdig on-premise is exactly the same software, but you run it behind your firewall. It's annual only, and there's a minimum commitment required. Sysdig open source is what I showed you near the end. It's a CLI-based troubleshooting used on a single host with community support. With both Sysdig on-premise and Sysdig Cloud, we do have a fully featured API that allows you to get data out. Steve asked if we can take Sysdig metrics out and roll it up to another service that they already have in place. You could absolutely do that via our API, and you would integrate that yourself. All right, so I hope you really appreciated the demo. Talk is cheap though, and what I'd really like you to see you do is try it yourself. We do free trials, and they're really easy to get going, whether you want to do them. We try to do trials in the SaaS environment if you can, because it's faster and easier for you. But once you're in there, you can kind of see these core benefits of service-oriented performance management, application intelligent monitoring, and trace-driven troubleshooting. We think this is going to change the way you think and manage your systems, and we would love you to try it yourself. So thanks very much, everybody. I'm going to sit tight here in case you have any last questions. One last thing, we do this webinar every single week. So if you've got colleagues you think would benefit from seeing this, please send them our way. The sign up is directly available on sysdig.com. Thanks again for joining, and I will sit tight in case you have any additional questions. All right, I think we questioned everybody out. I'm going to end the webinar now. Thanks again for joining. Really appreciate it. If you need to contact us for anything else, feel free to email us at info@sysdig or reach us on Twitter. Thank you.